This is Mr. Ng going over Precalculus Quiz number 15, Chapter 4, Section 4 to Section 5, essentially all of the trig graphs, March 27, 2018. Question number 1, multiple choice. Which function represents the graph below? So, first thing I should recognize that it's a tangent. I know it's a tangent because it has a snake. They all have tangents. Okay. The next thing I notice is that the period for tangent finishes from negative pi to pi. Okay, well, this is a distance of pi, and this is a distance of pi, so that means it's 2 pi. Well, tangent has a period of pi over b. This was a common mistake when students were graphing tangent. So all I have to do here, I can just cross multiply. I get 2 pi b equals pi, and I'm solving for the b value so that I can figure out which equation. So there I have, I can just divide both sides by pi. You get 1 equals b times 2, and divided by 2, and you get b equals 1/2. So I'm looking for a b value that has 1/2, and the only one that has the correct answer is letter choice B. Question number 2. Which of the following is an x-intercept of the graph of y equals 1/3 sine pi over 4 x? Now, any problem that they're asking me about a graph, compare and contrast, what's the error, I'm always just going to do the problem. So over here, I just got my a value is 1/3. My b value that's in front of your x, my coefficient there, my b value is pi over 4. I have sine, so the period is 2 pi over b. So I'm going to put my b value of pi over 4 there. So I get 2 pi divided by pi over 4. When it is division, I'm going to change it to multiplication and take the reciprocal. I'm going to put 2 pi over 1. When I multiply across, I get 8 pi over pi, or you can just cancel your pi's there, and you get your period to be 8. So if I have sine, I know it's going to start at 0, end at 0. I have an amplitude of 1/3. So 1/3 to negative 1/3. And I'm looking for the x-intercepts. Well, if these values are 8, half of 8 is 4. 4 plus 8 divided by 2 is 6. 0 plus 4 divided by 2 is 2. Remember, if you get stuck on where to start and where to end, you could have put this between our inequality. Everyone say to the right. Right. So if I had to put something into the inequality, which a lesson struggled on the pre-response, I'm putting it between your period. So in this problem, you're putting in pi over 4x. And then here, to clear that, you're going to multiply by the reciprocal. And you'll recognize you'll get between 0 and 8. And that's why I started at 0 to 8. So here are my x-intercepts, 0, pi, 4, and 8. And those options, only A is the correct answer. Question number 3. Which of the following functions has a period of 2? Well, tangent and cotangent have a period or an equation of pi over b. So if they're telling me the answer is period is equal to 2, here I'm just solving for the b value, and then I can use that to figure out which trig function. So pi over b equals 2. To solve for b, I'm cross multiplying 2b. So there I get b equals pi over 2. And there I'm looking for all the tangents and cotangents. Cotangent and tangent that have a b value of pi over 2. Notice how it's none of those, so I can eliminate. Now I'm going to go ahead and check. Oh, that one also has, that one's a 1 over 2, not pi over 2, so automatically your answer is C. Okay? Now when I do multiple choice questions, I never just say, well, I've eliminated the other 3, therefore this is the answer. I'm still going to use the other, make sure I know that this one is correct. So this is cosecant. It has a period of 2 pi over b equals 2. Cross multiply. Divided by 2. B is equal to pi. And that's the only one that has a b value equal to pi. So the answer is Last question. I'm going to go over, find the phase shift of the graph of the function. Oops, repeated the directions. Number 4 says y equals sine x plus pi over 2. Remember, I have the phrase add to x. They're adding to x and go west or left, so the answer is left pi over 2 units. Okay, that's a trick, not necessarily the best. So I like to write it as sine of x minus negative pi over 2. And when you write them with letters, it's a sine b parentheses x minus c. And then there, you recognize that your c value is negative pi over 2. So when you graph it, negative pi over 2 there is the idea of going shifted left. Alright, question number 5. We need to match the graph with its function. Sorry, it's kind of small. So what I decided to do is I just took the first one, and I decided actually not to work with the fractions. Do you notice how 2 sine 1/2 x and 2 sine 2x? So basically I'm trying to figure out which of the two graphs is 17 and 19. Well, I decided not to work with a fraction, I worked with this one. So my b value is 2. For sine, the period is 2 pi over b. So if I put a 2 here, I'm canceling the 2's. My answer is pi. That means a sine graph has to finish by pi. Well, this one starting up here, ends up here, that's cosine. This one looks like sine. And this one needs to finish by pi, so the answer for number 19 is D. Again, I know it's D because it starts at 0, ends at 0, and does so by pi. Do you see that? That means the other sine graph, 2 sine 1/2 x, has to be choice B, because it starts at 0, ends at 0. For number 20, I took then the tangents, because I have tangent 1/2 x and tangent 2x. I did the same thing. I decided to skip the fraction and just work with the 2. My b value is 2. But the big thing about tangent and cotangents, its period is pi over b. So here, if I put a 2, that means I'm looking for pi over 2. So the tangent graph finishes that little snake by pi over 2. So if I look at this graph, notice how there's my snake, and notice how it finishes its graph by negative pi over 4 to pi over 4. So this is a distance of pi over 2. Remember, you can just take the absolute value there. So pi over 2 plus pi over 2, or 2 pi over 4 plus 2 pi over 4. 1 pi over 4 plus 1 pi over 4 equals 2 pi over 4, which is, what? Try that again. Pi over 4 plus pi over 4 gives me 2 pi over 4, which is pi over 2 when you reduce it. So number 22 is C, and that means the other graph, F, is the other tangent. So really, if you think about it, I'm only working through half the problems, and it helps me choose the other one. You could work through all 6 if you wanted to. Then I did the cosine. Again, I worked with 2x, so my b value is 2. Remember, for cosine and secant, it is 2 pi over b. And then I cancel, then I have pi here, so I'm looking for a graph that finishes a cosine by pi. Here is cosine, starts at 2, ends at 2, and it finishes it by a period of pi. If I look at the other graph, that would be number 18, that would be E, which I haven't done yet. So it starts here at 1, ends at 1. Notice how this one's finishing by, that's 2, so that'll be 4 pi. Do you see how it's finishing by a period of 4 pi? So this graph will be 2 cosine 2x, which is A. So 21 will be A, and then this choice will be the other cosine problem, which is 18. 18 will be B. So those are 1 point. Alright, number 8. 2 of my 100 students couldn't copy from the board. I wrote it on the board which trig ratios to use, right? It wasn't kind of like pick your own, what's your favorite one, so I actually had 2 students just write down whatever they wanted. So for period 4, you were asked to graph for question number 8, y equals 3 times tangent of pi x. They're actually say graph the following trig function over 1 period. If you graphed it over 2, I did not penalize you. Be sure to include a table of values and label your axes clearly. So the first thing I did is I wrote the letters above it. A tan bx. So my A value is 3, my B value is pi. Okay, pay attention. Here's the number one mistake for just graphing tangent. The period is pi over b. Look on your paper. Pi over b, not 2 pi over b. Okay? So if I put in b, here was another mistake. Something over itself is equal to 1. Right? Think about it. X divided by x, 3 divided by 3 equals 1. The period is 1. Okay, here's another common mistake for students who are just graphing in general. Okay? They're not sure where the graph starts and ends, especially if there are parentheses to do a shift. So let me teach you how to do it without a shift, and you just do it with the shift. For example, number 9 has the parentheses. So here, down here, your pi means that it's between 0 and pi. The question is, what do you put in here? Well, you look up to your equation, your function, and as long as you move the d value in front, that means all you're left with on the right side of the trig function is your b and your c value. All of that on the right side, whether you factored or not, goes between 0 and pi in this case for tangent. I divide by pi on both sides, and I get 0 is less than or equal to x, less than or equal to 1. I'm going to start at 0, and I'm going to end at 1. Okay, what does that tell me to do? That tells me of the 5 x values, 0 is the first one, and 1 is the last one. If I cut this in half, 0 plus 1 divided by 2 gives me 1/2. Midpoint between 0 and half of a dollar is 25 cents, is a quarter. Between a half of a dollar and $1 is 3/4 of a dollar and 3/4. These are my x values, 0, 1/4, 1/2, 3/4, 1. Okay. Now, if you think about the order of operations, you're doing everything in this parentheses first. Do you see that? You have your x value, then you're multiplying. So now I'm going to multiply each of these by pi. 0 times pi is 0 pi, or 0. 1/4 times pi is just pi over 4. Pi over 2, 3 pi over 4, and just pi. Now, here is the golden row. I call this the golden row because this is what you need for each of the trig values, especially for tangent. You're going to have 0, pi over 4, pi over 2, 3/4 pi, and pi. That means when you're graphing tangent and you don't get this golden row, you did something wrong. Now I need to find tangent of these values. If I take tangent of these values at 0, tangent is y over x. That would be 0 divided by 1, which is 0. At pi over 4, the order pair is radical 2 over 2 and radical 2 over 2. Tangent is y over x. So this expression over itself, same thing over itself, is equal to 1. Tangent at pi over 2 is 1 over 0. 1 divided by 0 is undefined. At 3 pi over 4, that's this middle one here. Remember, anything to the 4, I'm using my unit circles, negative radical 2 over 2, comma radical 2 over 2. That would be this expression over itself equals 1, but you have a positive divided by negative, so that's going to equal negative 1. And then you have tangent at pi, the order pair is negative 1, 0. Again, you're looking for y over x. 0 divided by negative 1 is 0. Then I'm going to multiply my answer by 3. 3 times undefined is still undefined. Negative 3 and 0. So if you're stuck on this part up here, what to do? You're just going from right to left. Move the d value in front, and you're basically working from right to left. Now, the first thing I always like to do is I always like to graph the undefined. So that is an asymptote. This is a ruler. I would literally put a ruler, if I didn't think you drew straight, I put the ruler on there. I'm looking for a nice straight line. Asymptote. Then at 0, I'm graphing 0. And at 1/4, I'm graphing 3. Remember, for tangent and cotangent, those 3 points in between the asymptotes, they're going to form a nice straight line, 3 in a row. Do you see that? If I had expanded it this way. Then at 3/4, I'm going to have -3. And at 1, I'm going to have 0. And if you needed to graph an extra one, there would be your third point. So essentially, I only have half the snake there. Let me kind of sketch out the rest. And of course, you probably have another asymptote on this side. Come on, Miss Ring, straight line. Okay, so how did I award you points? Let's see if I can do that one. If I put a little check mark by your period, in this problem you got 1, you got 1 point in addition to just trying, so you got a total of 2 points. If you got the x-intercepts, I added another point, or if you missed it, I subtracted 1. If you got the basic graph of tangent, the snake in the right direction, let's just say you graphed it incorrectly, so the shape of the graph and then the accuracy. I gave you a point for the table if that was correct, or took away a point if it was wrong. Your period. Now, I'm actually not looking for this, but you realize that this is kind of like the key, especially if there's a horizontal shift or phase shift, so you might as well just do it all the time. And then 1 point for your x-axis. So, this format's probably going to look very similar to Friday's, where I might give you a graphing question. And it might be worth more, so it's not just the 4 points, it's the 6 points, and I'm giving you this amount of space. Alright, for question number 8 for period 5, I asked you to graph y equals 3 cotangent pi x. Remember, this was written on the board. Out of my 3 classes, 2 students decided to write down 2 random trig functions and try to graph those. Pay attention to what I ask you to do. Graph the following trig functions over 1 period. Be sure to include a table of values and label your axes clearly. I'm just going to first tell you how I graded the problem out of 6 points. On your graph, I'm looking for the basic shape. Another point for the graph accuracy. 1 point for a correct table. 1 point for the x values. 1 point for the period and 1 point for the x-intercepts. Let's graph this. The first thing I did is I wrote the letters above it, A cotangent B x. My A value is 3, my B value is pi. Here's the first common mistake students had. Tangent and cotangent, its period is pi over B, not 2 pi. If you missed that, write that in your formula sheet. So if your B value is equal to pi, something divided by itself is equal to 1. The period and its length is equal to 1. The question might be, what do you start with and what do you end with? Well, regardless if you have parentheses or not, move the constant, the D value, over. And then everything to the right, that's what you're putting in between this inequality. So basically put this right there. And your inequality here, you're starting with 0, and then you're ending it with this value here. So if this is a 1, you just put a 1 here. And then you're basically solving inside here for x, and this tells you where to start and where to end. From here, then I'm just finding the halfway point between 0 and 1. That's 1/2. Think of it as like half of a dollar, right? 2 quarters out of 4 of them make $1. So 2 out of 4, halfway between that is 1/4. between half and 1 is 3/4. These are my x values now. 0, 1/4, 1/2, 3/4, and 1. Now, when you're looking at this here, you're essentially doing Pemdas. You're doing what's in the parentheses first, so you're writing down the x values, and then you're multiplying them by pi. So I'm multiplying this by pi. Multiply by pi. Pi times 3 is 3 pi. 3 pi divided by 4 is 3 pi over 4. Pi times 1 is just pi. Everyone say the golden row? Here is your golden row for both tangent and cotangent. Now some of you thought the golden row was just 1, 0, negative 1, 0, 1. Well, that's for cosine. Or some of you put here 0, 1, 0, negative 1, 0. Well, that's for sine. For cotangent, when you're looking at these values, you're using your unit circle. Remember, cotangent is x divided by y. So when I look at cotangent at 0 here, I'm looking at this order pair is 1, 0. It's a quadrantal. So x divided by y is 1 divided by 0, which is undefined. At pi over 4, the order pair is radical 2 over 2 and radical 2 over 2. 1. The same expression over itself is equal to a positive 1. At pi over 2, the order pair is 0, 1. 0 divided by 1 is 0. 3 pi over 4. The order pair is negative radical 2 over 2, comma radical 2 over 2. So again, I'm just taking this expression divided by itself. It's identical, so it's going to equal 1. But this is a negative divided by a positive, so you're going to get a negative 1. And then at pi, negative 1 divided by 0 is undefined. And then the last thing I'm going to do is here multiply by 3. 3 times each of these values, so 3 times undefined is still undefined. 3 times 1 is 3. 3 times 0 is 0. 3 times negative 1 is negative 3. And 3 times undefined is undefined. At 0, I'm going to graph my undefined with my ruler. And at 1, I'm also going to put undefined. That's the dashed line, the asymptote. And at 1/4, I'm going to graph 3. 1/4, there's 3. At 1/2 is 0. And 3/4 is negative 3. Remember, for tangent and cotangent, you're going to make this straight line of 3 points. Does that make sense? And you have a reverse snake. It's reverse to what tangent is. Alright, let's go ahead and now question number 9. You guys were asked to do cosecant. This is the chart for how I assigned the questions. So let's go ahead and graph cosecant. There it is. For question number 9 for cosecant, it says y equals 3 minus 6 cosecant, parentheses 2x plus pi over 2. Well, there's 2 methods of doing this problem. Show you over here. Method number 1 for graphing cosecant and secant, you're basically graphing its reciprocal. So for cosecant, we're really graphing what? Sine. This is what we did in class, right? And then we graphed sine, and then we erased it, and we graphed it above and below, right? Some of you are doing something different. On the table of values, you're kind of going through and using sine, and at the very end, you're taking the reciprocal of those values and doing cosecant. That's okay to do, and I'll show you the solutions for both of those. The first thing I did is I recognize I have a parentheses. I don't have a b value, so I have to factor. Take out the greatest common factor. Well, I know there's a 2 here, so how do I get pi over 4? Well, if you do something like this, let's just say this is a box. Let's just say it says plus a box. 2 times this box is going to equal pi over 2. 2 times the box equals pi over 2. Well, how do you solve for the box? Well, I'm going to divide by 2. Dividing by 2 is the same thing as multiplying by 1/2. Dividing by 2 is the same thing as multiplying by 1/2. These two cancel. Your box is equal to pi over 4. So this reads 2 times x plus pi over 4. Now you might be asking, why did I change the plus sign to a minus minus? It's because in the formula, I need a minus sign here. Why did I do that? Now I can identify. My a value is -6. My b value is now 2. My c value is now negative pi over 4. And my d value is equal to a positive 3. I have an amplitude of 6 for sine. My period here is 2 pi over b. 2 pi divided by 2 equals pi is my period, is its length. Negative pi over 4 basically means we have a phase shift left pi over 4. You can kind of see that in my final product. It's pushed off here, negative pi over 4. My d value is 3, which basically means we're going to have a vertical shift. We're going to push up the graph 3 units. Notice how this is not sitting at 0. This is probably the #1 mistake for a problem with the parentheses or the phase shift. How do you know where to start and where to end? How do you get those fractions? Well, notice how I move the d value all the way up to the front here. I have it here. Now you can see this big yellow box. Basically any of that is going to go in between 0 and 2 pi. I want to show you a quick side problem, and this should make sense algebraically. 2x, what do I have on the board? Minus 7 equals 18. Class, can you divide by 2 on both sides and get x minus 7 equals 9? The answer is no. You have 2x divided by 2 minus 7 over 2. So this would be incorrect. You can't just divide by 2 on both sides. Basically, you're doing Pemdas backwards to solve. So here to simplify. So if you were with me for 4 years, I would have taught you this. When you're simplifying, you use Pemdas right to left. When you're solving, you're actually going right to left. What does that mean for us? That means it doesn't matter what you pick in here to put in here. You could divide by 2 if you did this one here. But let's just say you just picked the original problem. 2x plus pi over 2. I'm not going to divide by 2 on all 3 columns. I'm going to do addition and subtraction first. I subtract pi over 2. That gives me negative pi over 2 less than or equal to 2x less than or equal to 3 pi over 2. Then at the end I'm going to divide each of the columns by 2. Remember, dividing by 2 is the same thing as multiplying by 1/2. 1/2 here, 1/2 here. That means I get negative pi over 4 and 3 pi over 4. My graph is going to start at negative pi over 4 and 3 pi over 4. How do I get the rest of the values? Negative 1 plus 3 is positive 2. 2 pi over 4 is what did I do wrong? Negative 1 plus 3 is 2. Oh, 2 divided by 2 is 1. 1 pi over 4. Then you have a nice one. 1, 2, 3. So that's negative 1, 0, 1, 2, and 3. So therefore your x values are going to be negative pi over 4, 0, pi over 4, pi over 2, and 3 pi over 4. Remember what I said? We're working basically from right to left. So I have my x values. You would not add first because in the order of operations it basically tells you to multiply first when you're simplifying. So in that case, I'm going to take my x values and multiply these by 2. After I multiply by 2, now I'm going to add pi over 2. Add pi over 2. And here, you should recognize the golden row for sine. Sine has 0, 0, 1, 0, negative 1, 0. Okay, this is where I saw a lot of students go wrong here. This basically means multiply by negative 6. So I'm taking that row now and multiply it by negative 6. And then this says add 3. The reason why it says add 3, because if you moved it over here, it would say plus 3. So I'm going to take all these values and add 3. Now this, here in purple, this is graphing sine, not cosecant. So my purple graph, negative pi over 4 is 3, negative 3, 3, 9, and 3. Remember, I taught you guys then, after you finish, to graph it above your x intercepts, because notice how it was shifted up 3 units. This is the x-intercepts. This is where your asymptotes go. And then above and below, so in this case below, where the bump is, you're going to graph your graph for cosecant. And then you would erase the purple graph. Okay? Now for the students who are using in the table of values cosecant, this is where I think, this is where you should have gone. The inverse, if you take these, this is 0 over 1, 1 over 1, 0 over 1, negative 1 over 1, and 0 over 1. And then if you change sine into cosecant, there you're going to get undefined, 1, undefined, negative 1, and undefined, and then you do the same thing. Multiply that answer by negative 6, and then add 3 to those values. And then this row here represents the graph in blue. Does that make sense? So that would be undefined, negative 3, undefined, 9, and then undefined, and you would graph it. Okay? So if I had to look at all the student work, what do I think the students are missing? They have difficulties finding between where to start and where to end. Factoring was a bigger issue, and then simplifying with the table. Let me show you guys what would happen if you didn't want to use my set of tables. Let's just pick a value. Let's just pick 0, because that's easy to work with. Essentially what you would do is this. Class, what's 2 times 0? 0. 0 plus pi over 2? Cosecant at pi over 2. 1, negative 1 times 1, negative 6 times 1, and then add 3. That's essentially what you're doing. Does that make sense? We're kind of just doing all the values all at once. So I again show you a different way of substituting and getting a value. You want to see another one? 3 pi over 4. Again, this is premise that you get the 5x values. 3 pi over 4. 2 times 3 pi over 4. And 6 pi over 4 is 3 pi over 2 plus pi over 2 is 4 pi over 2, which reduces to cosecant at 2 pi. That would be 0, right? Y over r. Negative 6 times 0, and 3 plus 0. And that's how I get this value. So the table is just kind of helping you work through all the problems at once. Alright, if you had the part that had graph secant, y equals 3 minus secant 2x plus pi over 2, then you're really writing this as y equals 3 minus 6 times secant, and then here what I did is I factored out a 2. If you don't know how to factor out, well, you'll notice there I need something like a 2. It says 2 times something equals 2x. Well, that is x. 2 times something, so let's just say this box here. 2 times the box is going to equal pi over 2. Well, if I divide by 2 here, then I get pi over 4. and this is a positive pi over 4, so the same way of saying pi over 4 is negative, opposite of a negative pi over 4. So that tells you my A value is negative 6. My B value here is now a 2. My C value is negative pi over 4. And then my D value, which is up front here, is D equals a 3. So it's a vertical shift going up 3. So how do you get the graph to go from your starting point and your end points of your graphs? Well, essentially what you're going to do is you're going to take, as long as your D value is up here in the front, everything to the right of the trig function. So basically one of these. This is what's going between the interval of 0 to 2 pi. So you can use the unfactored version, which I used, or you can use the factor version, 2 times the quantity x plus pi over 4, and you'll get the same answer. To simplify this problem, I'm just first subtracting pi over 2, and then you will divide by 2 and get negative pi over 4 to 3 pi over 4. So again, you can't divide by 2 here first. With these values here, this helps me get me the x values. And then I got negative pi over 4, so negative 1 plus 3 is a 2. And then 2 divided by 2 is 1, so that gives me 1 pi over 4. And then this would be 2 pi over 4, which is pi over 2. And then negative 1 plus 1 divided by 2 is 0. So these are my values. So here's one train of thought. I take my x values now, and basically I'm going to graph cosine. Because reciprocal of secant is cosine. If I graph cosine, which is in purple, and then I erase it, and then I go above and below, and that's my graph in blue, and that's my answer for for secant. So let's do that method first. So I have these x values, and then now I'm going to multiply by 2. And the reason why I multiply by 2 is because you have Pemdas. So to simplify, you go from left to right. So we're going to multiply first. So I'm going to take x times 2. 2 times negative pi over 4 is negative 2 pi over 4, which reduces to negative 1/2 pi, or negative pi over 2. 2 times 0 is 0. This becomes 2 pi over 4, which reduces to pi over 2. That becomes 2 pi over 2, which is pi. 6 pi over 4, which is 3/2 pi. The next thing I'm going to do is now add pi over 2 on, to each of these values. And when I do that, I get the golden row for both sine and cosine. These are the quadrantal angles. Cosine at 0, make sure you use your unit circle. So cosine at 0 is 1, pi over 2, that is 0, negative 1, 0, and then back up here to 1. And then from these values, you're going to multiply by negative 6. So take all these values and multiply by negative 6. And at the very end, then you're going to add 3 to these. So when I graph these, this last row here is my graph here in purple. Negative 3, 3, 9, 3, and negative 3. And so I graph those, and then for secant, I'm graphing those above and below. And then you can erase the purple, and then you have this as your graph. So how did I award you points? And I'm going to show you some variations how to graph. 2 points for the graph. So what I'm looking for here is the accuracy of the graph. And then within that point, I'm also thinking like 1 point for basically the accuracy of the graph and 1 point for the general shape of the graph. 2 points for the table. Well, what do you get for the table? These values are correct, and then your x values that you get. 1 point for the x-intercepts. So here, there. Is that 3? Negative pi over 4. Yeah, that should be up here. Let's play a graph. Down here. So essentially those are my x-intercepts, but they're pushed up 3. And then 1 point for the period. So in this problem, that would have been pi, and getting the interval to help you find your x values. Alright, let me show you a variation of which students are doing, which is fine. Just want to make sure you understand what you're doing, and there's some students who are kind of mixed. So this is what I've taught you in class, this is what we've done over and over again, watch some more videos. But the variation is this. Some of you are recognizing that secant is just the reciprocal of these values. Okay, so if you do that, so I make these, putting it all over 1, and then I take the reciprocal of that. So if I take the reciprocal of that as 1, take the reciprocal here as 1 over 0, which is undefined, negative 1, undefined 1, and then you're doing the same thing, multiply by negative 6, gives you negative 6, undefined, 6, undefined, negative 6, and then you're adding 3 to all of these. And then these values down here, let me show you, loop, that is negative 3, undefined 9, undefined negative 3. That actually shows up on your graph. So here would be at negative pi over 4 is this column, which is negative 3, and then your undefined in red, and then 9, and then your undefined, and then negative 3. So here, that's telling you to graph it this direction. So either of these two methods will work. Remember, in these table of values, as long as you get these x values, you can find out anything you know. Let me give you an example of that. Another way of action. Remember, this table might be confusing, so I want to give you a different way of understanding what we're doing. Let's just say I pick pi over 4. If I pick pi over 4 as one of my points, because you figure that out, 2 times pi over 4 is pi over 2, and then pi over 2 plus pi over 2 is 2 pi over 2, which is just pi. And then secant at pi, secant is r over x, which is negative 1, and then negative 1 times negative 6 is a positive 6, and then 3 minus 6 is negative 3. So I forgot what value we did. Pi over 2 gives me 3. Negative 1 times negative 6 is positive 6. Yeah, and that gives us 3 minus, no, what? Pi over 2 gives me, oh, we did, I think pi over 4. Let's try that again. Pi over 4 times 2 gives me pi over 2. Pi over 2 plus pi over 2 gives me pi. Secant at pi is r over x, so it gives me negative 1. Negative 1 times negative 6 is 6. 6 plus 3 gives me 9. So essentially what you're doing in there is just, there's another way of just evaluating x value to get a y value to graph it. Remember, that was at 6 points. I hope that was helpful for you.